Hey there! Have you ever stared at your professor's lecture notes on network flow monitoring and felt like you were trying to read a totally foreign language? Yeah, we've all been there. Well, today, we are going to crack that code together. So, you're looking at all these terms, IPFX, S-flow, sampling, and your head is just spinning, right? It feels like you're supposed to already know this stuff. I totally get it, and that is exactly why we're doing this.
So just take a deep breath. We're going to translate all that dense academic language into something that actually makes sense. I promise, by the time we're done here, you won't just get the concepts. You'll see exactly how they all click together.
Okay, here's our game plan for today. We're going to start with the big problem, why we even need this stuff. Then we'll define what a flow actually is, compare the big protocols you need to know, see how the whole system works, talk about managing all that data, and wrap it all up with the key things you've got to remember for your exam. So, let's dive right in. Why can't we just record everything that happens on a network? I mean, it seems simple enough. Well, the problem is just the sheer mind-boggling scale of it all. Trying to capture every single packet is what we call full packet capture, and honestly, it's like trying to drink from a fire hose. It's just not practical. It really comes down to two real-world limits. Throughput, that's how much data can even fit through the pipe at once, and storage, which is, how much space you have to save it all. The amount of raw data is absolutely massive. So we need a smarter way to figure out what's actually going on. And that smarter way brings us to the hero of our story, the network flow. This idea is the absolute foundation for everything else we're going to talk about. Instead of trying to drink from that fire hose of raw data, we're going to start summarizing the conversations. We're turning all that noise into a clear signal. So what is a flow? Think of it as a summary record of a single conversation on the network. It's identified by a few key things: the source IP address, the destination IP address, and the ports they're using. My favorite analogy is to think of it like your phone bill. The bill doesn't record your actual conversation, but it tells you who called you, when, and for how long. That's a flow. And building right on top of that, you have a flow stream. So if a single flow is one line item on that phone bill, a flow stream is all the related lines that make up one complete call or session. It bundles all that back and forth communication together so you can see the entire interaction as one thing.
Now, what if the network is so busy that even summarizing every single conversation is too much to handle? That's where a clever trick called sampling comes in. Instead of looking at every single packet to build our flow records, we just grab a statistical sample, maybe 1 out of every 100, or even 1 out of every 1,000 packets. It's a really important tool for managing gigantic networks.
Okay, so we get the concept of flows, but how do we actually make them? Well, that brings us to the major protocols, and there are really two big schools of thought here. You've got the NetFlow and IPFX camp, and then you've got the S-flow camp. And this table just lays it all out perfectly. On one side, you have NetFlow and its modern version, IPFX. These are flow-based. The router or switch is stateful. It actively watches traffic, remembers the conversations, and builds those detailed summaries, our flows. On the other side, you have S-flow. It's sample-based and stateless. It doesn't remember anything. It just grabs a random packet here and there and sends the whole header off for someone else to analyze. So going back to our analogies, NetFlow is the detailed phone bill. S-flow is like taking random, short recordings of calls. Both are useful, just for different things. So we have the data, we have the protocols, but what does an actual flow monitoring system look like? How do all these pieces fit together? Well, it's actually a pretty simple, elegant three-part system. Let's break it down.
First up, you have the sensor. This could be your router, your switch, or a special device that just sits there, watches the live network traffic, and creates the flow records. Step 2 is the collector. Its only job is to listen for those records coming from all the sensors and store them in one place. And finally, step 3, the analyzer. This is the fun part. It's the software you use to search, graph, and make sense of all the data the collector has stored. So, sensor creates, collector stores, analyzer explores. Simple as that.
All right, let's get real for a minute. Even though flows are way smaller than full packet captures, you're still creating a ton of data. You can't just store it all forever. You'd run out of disk space pretty fast. So you need a smart strategy for what to keep and what to throw away. And really, there are two main ways people do this. The first is time-based, super simple. You just decide, I'm going to keep the last 24 hours of data, or maybe the last week. The second approach is size-based. You say, I'm going to set aside 1 terabyte of disk space for this, and when that space gets full, the system automatically deletes the oldest data to make room for the new stuff.
This is often called a ring buffer.
So what does this look like in the wild? Well, here's a perfect example using a command line tool called tshark. This one command is actually using a mix of different retention strategies all at once. Let's take a look at what it's actually doing.
What's really cool here is how you can stack these rules. The file size part tells it to start a new file once the current one hits about a megabyte. The files part says, hey, only keep the last 5 files. That's our ring buffer. And the duration part tells it to start a new file every 24 hours, no matter what. It gives you this really precise control over your data storage.
All right, we have covered a ton of ground. So let's boil it all down to the absolute must-know facts. If you're studying for a test, this is the part you'll want to lock in.
Number 1. A flow is a conversation summary defined by IPs and ports. Got it. 2. NetFlow and IPFX give you that detailed phone bill with all the metadata. 3. SFlow is more like call recordings. It gives you samples of actual packets. 4. The system has 3 simple parts: sensor, collector, analyzer. And finally, number 5, you have to have a data reduction plan either based on time or size because storage is always limited.
So, I want to leave you with this question to think about. The whole point of flow monitoring is to cut through the insane amount of noise on a network so you can actually see the conversations. Now that you understand how to do that, what could you find? What security threat, what slowdown, what hidden pattern might suddenly become crystal clear? That right there is the real power of what you've just learned.